Hello everyone. In this video, we will understand the concept of functional interfaces and Lambda expressions which were added in Java 8. This is the agenda for this video tutorial. First of all, we'll understand what is a functional interface, followed by what is a Lambda expression. We will then see the Lambda expression syntax and various features. Now, after that, we'll see the examples that demonstrate the usage of Lambda expressions. The examples list include circle interface, which contains the calculate area method, payment processor interface, which contains the process payment method, net salary calculator interface, which contains the calculate net salary method. And finally, we'll see an example of the runnable interface, which contains the run method. So let's get started with the first question. What is a functional interface? A functional interface is that one which contains a single abstract method. You can see the definition and example here. In this example, we have an interface circle which has a single abstract method, and therefore it is called as a functional interface. Let's move on and try to see the question and answer of what is a Lambda expression. A Lambda expression is that one which provides a shortcut syntax to implement the method of a functional interface. You can see the definition and the syntax of the Lambda expression on screen. The syntax contains three parts. That is the part number one, which is enclosed inside the parenthesis. The second part is the pointer or the arrow symbol. And the third part is the method body, which is enclosed in the curly brackets. We will see more details about these three parts in the next few minutes. Okay, so before we understand how does Lambda expression simplify, or how does the Lambda expression shorten the syntax to implement the method of a functional interface, first of all, let us see the classic approach of implementing an interface in Java before Lambda expressions were added in Java 8. There were two possible syntaxes available. One is declaring a class, and the second one is using anonymous inner classes. However, I'm not going to discuss anonymous inner classes in this case. Okay, now first of all, let's see the steps of implementing this interface circle before the use of Lambda expressions. The step number one is we have to declare a class that implements the circle interface. Now let's see these steps in action using the code example. To demonstrate that, I'm going to create a new package, new project in Eclipse. The project name, let me say Lambda demo. Now inside the project, I want to create a new package, com.lambda.demo. And inside this package, I want to create a functional interface, that is the circle interface. The circle interface I have declared. Inside the circle interface, I want to define one abstract method, public abstract void calculate area. And inside this one, I want to declare one parameter, that is the radius that is used to calculate the area of the circle. And now if you notice, this is the functional interface because it has a single abstract method. Okay, now let me execute the steps that we are trying to learn here. We need to define a class that implements the circle interface. So first of all, let me define a new class within the same package. New class. Let me name the class as circle IMPL. Now this circle IMPL class implements the circle interface. Now this is step number one. The step number two, we override the calculate area method of that interface in the class. Now let us implement that. Go here and then add unimplemented methods. This is the place where we are overriding. Now inside this one, I'm adding the print command that prints the area of the circle, math.py, and then radius, and then radius. And this is step number two. And step number 3, we then create an object reference of the circle interface. Or maybe I'll create one more class here, new class, and let's say lambda test 1, lambda test 1. Inside this lambda test 1, I'm creating the main method. Now inside the main method, I want to execute this step number 3. We create an object reference of the circle interface. Now watch here, circle C1 equal to null. And please try to understand this is an interface and this is the reference of this interface. We cannot create object for an interface, but we can create an object to the implementation class of an interface. Currently, we are in step number 3. Please try to understand. We are trying to understand implementing a functional interface without using lambda expression, which was the case before the introduction of lambda expressions in Java 8. Now, step number 4, we create an object of circle IMPL class and then assign it to the object reference created in step number 3. So let's go ahead and implement this step in the code. We create an object reference. We create an object. So here what I do is new circle IMPL, and this is done. Step number 4 is completed. And step number 5, finally, we execute the calculate area method on that object. So let's implement that in the step code, c1.calculate area and 2.0, and that's it. So this is the approach of implementing an interface without using lambda expressions. That is, when lambda expressions were not there, we had to use something like this, or otherwise we had to use something called as anonymous inner class. Now, if we run this code, we get the output. Okay, and that's the case. Now, let's see the same process by making use of the lambda expressions which were introduced in Java 8. And these are the steps for that. Step number 1, we create an object reference of the circle interface. To demonstrate this one, maybe I create one more test class, lambda test 2. Okay, new class lambda test 2. Now inside this class, let me add the main method. Now inside this main method, I want to implement step number 1, that is creating an object reference to the circle interface. Circle C1 equals null. By default, I'm setting it to null. Step number 1 is completed. And step number 2, we define lambda expression and then assign it to the reference of circle interface. Now let's implement this step number 2 in the code. Now, if you remember, the syntax of lambda expression is of something like this one. The first part contains a parenthesis. The second part contains the pointer, the arrow symbol, and the third part contains the method body and then the semicolon, the statement termination. Okay, and since the parenthesis contains the circle interface method has one variable, one parameter which is of double radius, we have to declare that here. Okay, double radius. Okay, optional. It is optional to use the data type because that will be automatically taken by the compiler, radius, and then this is the pointer which connects this part and this part. Okay, here we have to type the logic to print the area of the circle. Math.py multiplied radius multiply radius. And this is step number 2 of the process. And step number 3, finally, we execute the calculate area method on that object reference that is created in step 1. The object reference here is C1. We execute the calculate area method. Please try to understand this entire portion is called lambda expression, which represents the implementation of the calculate area method declared inside the circle interface. Now we need to call this method by making use of this one. Let's say c1.calculate area. c1.calculate area. This time, let's say 4.2 or something. And now we can execute this one. We can see the output. Right? Something like this. We got the output. So this is the comparison between the lambda expression and without lambda expression. Now let's see the three different parts of the lambda expression. The lambda expression has three different parts. This is the whole syntax, and the first part contains the list of arguments that are required to implement the method. And if you see here the example, the first part contains the variable radius as a parameter, which is of double type. As I have already mentioned, declaring data type is optional. And the second part is the pointer, which links or which connects the method body and the arguments. Okay. And the third part is the method body. You see here, this is the method body, which is the third parameter, third part of the lambda expression. And this is the full example of the lambda expression. Now you can see the implementation of the functional interface using the lambda expression demonstrated in red color without using the lambda expression demonstrated in blue color. So the syntax that is demonstrated in blue color, it was used before the adding of lambda expressions in Java 8. Now you can see this is very simple shortcut to implement the method of a functional interface. The conclusion is lambda expression provides a shortcut syntax to implement the functional interface abstract method. Now let's move on and see the features of the lambda expression. Point number one, we can assign a lambda expression to an object reference. Now we have already seen that in case of the circle, this is the object reference of the circle interface, and this is the lambda expression that we have assigned it to the circle C1. Now let's move on and see the next step. Lambda expression can be passed as an argument to a method if the argument is a functional interface. Now let's see this code in action. Okay, first of all, let me declare one method here. Now inside the class test and lambda test2, I'm declaring one method, public static void call area. And to this call area method, currently it is empty. There are no parameters. I am declaring circle as a parameter. Please try to understand circle is an interface name. That means in order to execute this method, we have to pass an object of this one. Okay. And that object, we will pass it as a lambda expression. Now here, what I'm doing, C dot calculate area. And in here, what we do is, let's say 3.2 or something. Now, what we'll do is we call this method calculate call area from inside the main method. I am commenting this one. Okay, what I'm doing was here, let's say call area, and inside this call area here in this portion, we actually have to pass an object. Since we are making use of the lambda expression, since we are learning, we can pass lambda expression as an argument to a method if the argument is a functional interface. This is the method, this is the argument, and this argument is the functional interface. Here I can pass the lambda expression that will be pointed by this C. So you watch here, I'm typing the lambda expression, radius R, and then here I use the print command, math.py multiplied R multiplied R. That's all. Now, since this entire portion is the lambda expression, which is pointed by this C. Okay, now let me execute this code and we can see the output. That's the demonstration of lambda expression passed as an argument to a method. Okay, and the next feature of lambda expression can be returned from a method if the return type of a method is a functional interface. Now let's see this one in action in the code. Now let me comment this one as well. Okay, and I want to declare one more method that returns, whose return type is the functional interface circle. Public static, the return type is circle, get area, and here it is the keys. Now if you notice here, the return type of this method is the name of the interface circle, which is a functional interface. Okay, without lambda expressions, we have to create a circle class implementation, return that object. But now we are making use of the lambda expression, return, and then what I want to do, I want to use this entire code here. So return this one. The lambda expression is now returning. So this is nothing but object of the class that implements the circle interface behind the scenes. Now, if you want to call this method, we can call it, you watch here, circle C2 equal to get area. Now, when I do this one, when I make a call to this get area method, the get area method is returning a lambda expression. This lambda expression is captured and stored in the reference C2. Now, I want to call the calculate area method on the reference C2. Watch here, C2 dot calculate area 2.0. Now, let me run this code and we can see the output. Now, that's the case. So that is the feature number 3 of lambda expression. Now let's move on and see the next feature. If the number of parameters is only 1, then we can omit the parenthesis. Okay. Now you watch here, the number of parameters is 1 here. I'm omitting the parenthesis. This is feature number 1. Feature number 4. If the method body of the lambda expression contains a single statement, then we can omit the curly brackets. You see here, I'm omitting the curly brackets because the statement, the method body of the lambda expression has a single statement. However, if it has more than one statement, then we have to use the curly brackets. The next statement, if the method body of the lambda expression contains a single statement, then return statement is automatic. We do not have to use the return statement explicitly. That's about the features of the lambda expression. Now let's move on to the next point. The @ functional interface annotation. This annotation is used to declare that, to denote that an interface is a functional interface. Now let's see an example of this one. We have already declared the circle interface as the functional interface. On top of the interface name declaration, we have to use something like this one. The benefit and advantage of this functional interface is it restricts someone from adding an additional abstract method. For example, after I declare this one, and if I add one more abstract method, it shows a compilation failure. I want to add one more method. For example, calculate perimeter of a circle. Okay, if we add more than one abstract method in an interface that is declared with @ functional interface, then that will result in a compilation failure. You see here, invalid @ functional interface annotation. Circle is not a functional interface. Not only this part of the error, you notice we have already implemented the lambda expression. Everywhere we got the error. That means after declaring the functional interface, if someone tries to add extra abstract method inside that, that shows a compilation failure. That is the benefit of @ functional interface. Okay, so that's about the functional interface annotation and why do we need that. Okay, if we use this annotation to declare the functional interface, and if we add more than one abstract method, it results in a compilation failure. Okay, now let's move on and see the list of the few built-in functional interfaces added in Java 8. There are so many functional interfaces added in Java 8. A few of them are function, by function, consumer, by consumer, predicate, by predicate, supplier. And not only these 5 or 6, there are so many functional interfaces which are all declared in the package java.util.function. Now let's move on and see the examples related to lambda expression. First of all, let's see an example of the payment processor interface with a process payment method inside that. Now let me create the new interface, that is the payment processor. Okay, here I'm creating a new interface. The interface name is payment processor. And since this one has to be a functional interface, I want to declare on top of this one @ functional interface. The moment we add it as a functional interface, we immediately see an error in the interface because there is no single abstract method. At least I have to do that. So public abstract, let's say void process payment. And this process payment method takes one parameter, which is of payment, which is of string, and that represents payment mode. That represents whether the payment is done using credit card, debit card, etc. Now this is done. Now let's create one more class to implement this payment processor by the syntax of lambda expression. Now I'm creating one more class. Okay. And the class name, let's say payment lambda. Payment lambda. Now inside this class, I want to add the main method. Now, what are the steps to implement the functional interface lambda expression? First of all, we have to declare the pointer, that is the reference payment processor P1, and this is the step number 1. We declare an object reference to the functional interface, and the step number 2 is to this object reference we have to assign the lambda expression. So here, what are the different parts? Part number 1 is the parenthesis. Part number 2 is the pointer. Part number 3 is the curly brackets, the method body. And since there is one object here, that is one parameter here, payment mode. And if you remember, we can use the data type or we can omit it. Okay, I'm removing the data type. And if you remember, if the number of arguments is only 1, we don't have to use the parenthesis, which is optional here. So I have removed the parenthesis. And here, what I'm doing is my program contains more than one statement. And that's the reason I'm using the curly brackets. So inside this method, what we do is we check if payment mode is equal to, debit card, let's say debit card. And if it is a debit card, let's do some print command. Let's say payment done via debit card. Payment done via debit card. And else, if the payment is made using credit card, let's say I copy and paste this one. If the payment is done using credit card, and then we print the output payment done via the credit card. Payment done via the credit card. So this is the implementation of the lambda expression. First of all, we have declared an object reference to this interface, and this lambda expression is assigned to this P1. And then the next step is we need to call the method process payment on this P1. We do that here. And then we pass it P1 dot process payment. And in here, I'm passing the input as payment type, payment mode as debit card. Okay. And let me print a new line and again call the method using payment type as credit card. Let's say this is debit card and this is credit card. Now let's see the output. When we run this application, we see payment done via debit card and a blank line followed by payment done via the credit card. Now that is the example of payment processor that demonstrates the usage of the lambda expression. Now let's move on and see the next example, net salary calculator, which has a method calculate net salary. Okay, and which takes two input parameters, that is the gross salary and the deductions. Let's go ahead and see the code in action. Now let me create the interface for the net salary calculator. New interface, net salary calculator. And this interface, I want to declare it as functional interface @functional interface. And in here, I want to declare the method public abstract void calculate net salary. And the calculate net salary method, I want to give two parameters. The first one is the gross salary, and the second one is the deductions. Now this is done. Now let's go ahead and create a class to demonstrate the lambda expression for this one. I'm creating one more class, lambda salary lambda, new class, and in here salary lambda. Now inside the salary lambda method class, I want to add the main method. Now here, what is the first step? We need to declare an object reference to the net salary calculator. Net salary calculator NS1. We have declared the object reference. And what is the second step? We have to create a lambda expression here and map it to this one. The three different parts of lambda expression, this is part number 1, this is part number 2, and this is part number 3. Now, since we have two parameters, we definitely have to use the parentheses there. So the first one is gross salary and the second one is deductions. Okay. And since we have a single statement, I can release or ignore the curly brackets. System.out.println. What I want to do is here I want to print net salary is equal to, and then here I want to print the calculation of gross salary minus deductions. Gross salary minus deductions. Something like this one. And I want to let me push it to the next line. So this is the entire portion of the lambda expression. Okay. This is the entire portion. Since I have a single statement in the method body, I need not use the curly brackets. This is purely optional. And the second step is we have to call the method on NS1. NS1 dot calculate net salary. Let's say the net salary is some 10,000. Okay. And the deductions, let's say some 500. And now let me run this program and we can see the output. This is how it works. Net salary calculator. And let's go ahead and see the next example, the runnable interface, which is a built-in interface in Java, which is used to create multi-threaded programs. The runnable interface has a single abstract method, that is the run method, which takes no parameters. Now let's go ahead and see that. Okay, I'm creating a new class that demonstrates the runnable interface. Let's say new class runnable lambda. Now inside this class, I want to add the main method. Now in the main method, what I want to do, runnable r equal to null. This is the first step. In the second step, we have to provide the lambda expression, first part, second part, and third part. And if you remember, the run method has 0 parameters, and therefore we will place this empty parenthesis as it is. We don't add any parameters here. And this one is the method. We write some code here. Okay, for int I equal to 0, I less than or equal to 10, then I plus plus. And inside here, we add the print command that prints the value of I. Okay, I equal to plus I. Altogether, this entire portion represents the run method of the runnable interface. We then have to pass this run method object, runnable object, to the constructor of the thread class and start the thread. So let's do that. So here what I'm doing, new thread of r dot start. And let's run this program. We'll see the thread in action. Now we got the output. And that's about the lambda expressions with various examples and various features and expressions of the lambda expression. Thank you so much for watching. If you like it, hit the like button. If you don't like it, hit the dislike button. Subscribe, share, and leave your comments in the suggestions in the comments. Thanks again.